In this video we're going to perform the integration of the cotangent of x divided by the cosine squared of x plus the cosine of x plus 1. Now this is a very challenging integral to do, and it will involve quite a few steps, so if you could please bear with me throughout the process. But if you ever come across something like this, remember there are four primary analytical methods of integration. The first one is the power method, which is to simply increase the power by 1 and divide by the new power. And this applies mostly to polynomial integration. The second is to manipulate the equation so it becomes of an integratable form, and this is like partial fraction decomposition. The third method is to use a substitution, and the fourth is to use integration by parts. And for this integral we'll use a combination of substitution and manipulation to achieve the desired result. But if you persist and practice and use a bit of trial and error, you'll find that these sort of integrals come to you more naturally. So the key is to practice. So with this integral, let's rewrite the cotangent of x as the cosine of x on the sine of x. So this is the division identity of the cotangent of x, and it is divided by the cosine squared x plus cosine x plus 1. So this effectively means it is multiplied by 1 over cosine squared of x plus the cosine of x plus 1. And this of course is the expression that we will be attempting to integrate. I said we would use a combination of substitution and manipulation, so let's use a u-substitution, and let's let u equal cosine of x. This means the differentiation du by dx is equal to the negative of sine x. So I can write dx as equal to the negative of du on sine x. So the integral becomes the integral of u on sine x by 1 over u squared plus u plus 1 by negative du on sine x, and this simplifies to the integral of negative of u on sine squared x by u squared plus u plus 1 du. Now sine squared of x, we know the identity of cos squared of x plus the sine squared of x is equal to 1. So then sine squared of x is equal to 1 minus the cos squared of x, and that's equal to 1 minus u squared if we use our substitution. So the integral becomes the integral of negative u on 1 minus u squared by u squared plus u plus 1 du. Now I'm going to take this negative into this expression here, so it becomes the integral of u divided by u squared minus 1 by u squared plus u plus 1 du. Now u squared minus 1 is a difference of two squares, so we can write this as u plus 1 u minus 1 by u squared plus u plus 1, and of course we're dividing u by this. So now I have an expression that I can separate out into partial fractions. So I can write this as a constant a divided by u plus 1 plus a constant b divided by u minus 1 plus c times u plus d, and the reason why I have a linear factor at the top is because the polynomial here is of degree 2, so the numerator is always 1 degree lower than the denominator, so it's cu plus d on u squared plus u plus 1. Okay, so to combine the denominator, I'll get u plus 1, u minus 1, u squared plus u plus 1, so that's pretty straightforward. But now this constant a does not have the factors of u minus 1 and u squared plus u plus 1, so I'll multiply that. So I get a by u minus 1 by u squared plus u plus 1. The constant b does not have the factors of u plus 1 or u squared plus u plus 1, so I'll multiply these. So it's b multiplied by u plus 1 by u squared plus u plus 1. And the cu plus d does not have u plus 1 or u minus 1, so we have u plus 1 and by u minus 1. Alright, so the next step is to tediously expand and simplify this expression. So if I leave the constant at the front, I will get u cubed plus u squared plus u minus u squared minus u minus 1 plus b by u cubed plus u squared plus u squared plus u plus 1. Now for the third one, this is effectively multiplying by u squared minus 1. So first I have cu cubed minus cu plus du squared minus d, and this is all over as per the expression above. Now simplifying further, I have a outside of u cubed. These u squareds take each other out, and same these u's will take each other out, so we'll get a outside of u cubed minus 1 plus b u cubed, and u squared plus u squared gives us 2u squared, u plus u gives us 2u plus 1, and we're left with cu cubed minus cu plus du squared minus d, all over as per the expression above. So now expanding this out, I have au cubed minus a plus bu cubed plus 2b u squared plus 2b u plus b plus cu cubed minus cu plus du squared minus d. And this is still all over the denominator as above. Okay, now if I factor out the u cubed terms, if I factor out a u cubed, I'll get u cubed outside of a plus b minus c. So these are the u cubed terms eliminated. If I factor out a u squared term, I'll get u squared outside of 2b plus d. Now factorising a u, I will get 2b minus c. Okay, this u squared term has been eliminated, and what we're left with is b minus d, all over the denominator as above. So what we do now is just equate these coefficients. Two equal u over the above denominator. And of course we get the equations a plus b minus c is equal to 0. Actually, this should be a plus c, sorry. So a plus b plus c is equal to 0. We have 2b plus d is equal to 0. We have 2b minus c is equal to 0. And we have b minus d is equal to 0. My apologies, 2b minus c is equal to 1. And my apologies again, there should be a minus a here. So b minus d minus a is equal to 0. And the next step is to solve these equations simultaneously to get a, b, c and d. So if I use an augmented matrix, I have 1, 1, 1, 0 is equal to 0. I have minus 1, 1, 0, minus 1 is equal to 0. So this is the fourth equation, so negative a plus b minus d. Next I have 0 and 2b minus c plus 0d is equal to 1. Then I have 0a plus 2b plus 0c plus d is equal to 0. Now let's perform some row operations. So if I add row 1 to row 2 to form a new row 2, I will get 1, 1, 1, 0 and 0, which remains. 1 plus negative 1 is equal to 0. 1 plus 1 is equal to 2. 1 plus 0 is equal to 1. And 0 plus negative 1 is equal to negative 1. And 0 plus 0 is equal to 0. And let me write down all of the remaining rows. Okay, so let's divide each of these rows by 2. So we'll get 1, 1, 1, 0 and 0, 0, 1, 1 half, negative a half and 0. We'll have 0, 1, negative a half, 0, a half, and then we will have 0, 1, 0, 1 half and 0. Now let's subtract row 2 from row 3 and we'll form a new row 3 from this. So we'll have 1, 1, 1, 0, 0, 0, 1, a half, negative a half, 0, 0. So 1 minus 1 is equal to 0. A half minus a half is equal to negative 1. 0 minus negative a half is equal to 1 half. A half minus 0 is equal to a half. And let's also subtract row 4 from row 2 to form a new row 4. So we'll have 1 minus 1 is equal to 0. A half minus 0 is equal to a half. Negative a half minus a half is equal to negative 1. And 0 minus 0 is equal to 0. Now let's multiply row 4 by 2. So copy 1, 1, 1, 0, 0, 0, 1, half, negative a half, 0, 0, 0, negative 1, a half, and 0, 0, 1, negative 2, a half, 0, sorry. And let's do one more row operation. So if we add row 4 to row 3 to become the new row 4, we have 1, 1, 1, 0, 0, 0, 1, a half, minus a half, 0, 0, 0, minus 1, a half, and a half, and 0, 0, 0. So minus 2 plus a half is equal to minus 1.5, so that's minus 3 on 2. And a half plus 0 is equal to half. So we have minus 3 on 2 d is equal to 1/2. So this means that d is equal to negative 1/3. And then we have minus c plus a half of d, so minus 1/3 is equal to a half. So this means that c is equal to minus 2/3. We have b plus a half of minus 2/3, which is c, plus minus a half of minus 1/3 is equal to 0. This means that b is equal to 1/6. And finally we have a plus 1/6 minus 2/3, so a plus b plus c is equal to 0. So this means that a is equal to 1/2. Okay, so we have the fraction u on u squared minus 1 by u squared plus u plus 1 equal to 1/2 over u plus 1 plus 1/6 on u minus 1 plus minus 2/3 u minus 1/3 on u squared plus u plus 1. Now integrating both sides with respect to du, I can write the integrals on the right hand side separately. So we integrate each of the components. The first two are very straightforward. It simply comes out to be 1/2 of the natural log of u plus 1 plus 1/6 times the natural log of u minus 1 plus the remaining integral of negative 2/3 u minus 1/3 divided by u squared plus u plus 1 with respect to u. Okay, so for this integral, if I factor out a 1/3 or a minus 1/3, I will get minus 1/3 outside of the integral of u plus 1 over u squared plus u plus 1 du. And what we have here is a case of, see how the numerator is the first derivative of the denominator. So what we have is a case of the integral of the first derivative of a function over a function, and the result given by this integral is the natural log of the function. so the natural log of the denominator, and of course plus an integration constant. So this integral is equal to negative 1/3 by the natural log of u squared plus u plus 1 plus c, of course. So the entire integral is equal to a half of the natural log of u plus 1 plus 1/6 of the natural log of u minus 1 minus 1/3 by the natural log of u squared plus u plus 1 plus an integration constant c. And of course we can't forget that we made the substitution of u is equal to the cosine of x. So plugging this back in, we have the result equaling 1/2 by the ln of cos x plus 1 plus 1/6 by the ln of cos x minus 1 minus 1/3 by the ln of cos squared x plus cos x plus 1 plus the integration constant c. And wow, this is the final solution that we were looking for. And please satisfy yourself that this is the integral of the cotangent of x divided by the cosine squared of x plus cosine x plus 1 by performing the derivative of this result. So I think this video has been long enough. I'll leave it there. Thanks for watching, and please give me a thumbs up if you have found this to be helpful, and please share. And if you have any questions, please ask by using the comments below, and please subscribe for any future videos that may help you with your studies, and best of luck.